My name is Adam Thomas. I lead the Data Science and Sharing team in the NIMH Intramural Program. It is my pleasure today to welcome Chris Gorgolewski. Chris got his PhD from the University of Edinburgh just a few years ago, but he's quickly become a leader in advancing open and reproducible methods in the neurosciences. His works include such things as NeuroVault, NiPipe. He spearheaded the creation of the OHBM Replication Award. He was the co-director of the Stanford Center for Reproducible Neuroscience, and he's largely responsible for the creation of the wildly popular Brain Imaging Data Structures Standard, better known as BIDS. Having solved all of the reproducibility problems in neuroscience, he's now expanded his ambitions to create an open ecosystem for all of science. If you could help me welcome Chris Gorgolewski.
Thank you so much for this very kind introduction, and obviously those problems are not solved, and I contribute a little bit, which I'm very proud of, with help of many, many people. So today I'm going to talk about a new Google product called Dataset Search, and tell you how we are trying to do this together with a broader community and ecosystem of data providers and repositories out there. But before I begin, I want this talk to be interactive, so please don't hesitate to interrupt me and ask questions. I'm here to clarify things, and I'm here to provide information. And hopefully there will be also, in addition, some time at the end for dedicated question session. Okay, so let's start with open data. We know from various studies that open data does improve research quality. There have been papers showing that data sets that include shared data have fewer statistical mistakes. We know it saves money. We know that research done reusing existing published data sets save large number of taxpayer dollars. For example, recent paper by Milham is showing that FCP Indy, one of the initiatives in data sharing neuroimaging, saved something around $1 billion. And we know it also promotes innovation because reusing data across fields leads to new ideas. And it also allows data produced in an academic environment to be reused in more commercial environment and leads to commercializations of scientific discoveries. But to think more about the open data and data sharing, it's good to have a framework. And Wilkins and others proposed a framework called FAIR, which is an acronym for Findable, Accessible, Interoperable, and Reusable. And maybe a vote of hands. Who has heard about FAIR, the acronym? Excellent, great. So it's a very useful way of thinking about what does it really mean for data to be useful. And I'm going to focus here on the very first in this acronym, the very first letter, which is findable. And FAIR defines findable as having persistent identifiers, as having been described with rich metadata, and that metadata being registered in a way that makes it searchable. And the identifier also needs to be specified in the metadata. And that aspect is what we are trying to help with. So why does it actually need helping? It's because there isn't one single data repository that everyone deposits their data in, and this is this one place you go to, and you know that if the data is not there, it doesn't exist. There are over 2,000 different repositories listed in Free Data. Nature Scientific Data, for example, recommends something around 58 different repositories, both field-specific and generic. DataCite lists 1,600 different data centers that are listed as publishers of DOIs related to data. And there are many, many different data repositories out there. And that's why the discoverability or findability is something that needs to be solved. Because if we want to increase reuse of data, we need to make it easy for people to find relevant data sets. And this, coincidentally, is what Google's mission is. So this is our mission statement, is to organize world's information, make it universally accessible and useful, which very much fits with the goal of increasing findability of research data. And this is why last year in September, we have released a new tool called Dataset Search. And it's basically what it says. It's a search engine dedicated to finding data sets. And I'm going to talk a little bit about how it works. And I will also spend a bit more time about what, from a data provider point of view, makes sense to do to make sure that your data is represented well in the search engine. And I'll finish with a few words about future directions that we are planning, especially in the context of the needs of funding bodies and crediting science. So, it is a search engine, but what makes it different is that the search engine over metadata. So that slight distinction between metadata and data means that what we are indexing is actually descriptions of dataset rather than the content of the dataset itself. And that might seem to be a not very important distinction, but it actually allows us to support various use cases that are common in biomedical research. For example, a lot of datasets require special agreements and approvals to get access to that data. And we can still index the information about the dataset without having to have the access to the data itself. And we can provide this information as search results to users, so then users can find the dataset and then go through our appropriate approval process to actually access it. The same goes for dataset that require certain fees. For example, the well-known UK Biobank project requires certain payment just to support the maintenance of the project. So their data is not also fully accessible without any additional hoops to jump through, but we can still index such data sets because we are indexing basically descriptions of data sets or metadata itself. And that metadata is used in search results. So this is how our user interface looks. And it's slightly different than the normal Google. It's a bit of a more rich description of the data set. On the left-hand side, you have the list of search results and this sort of infinite scroll kind of way. And on the right-hand side, you have details of one particular search result. And in that detailed information, you have the metadata of the data set. And this is what we index, and this is what data providers give us for us to be able to build the service. And that includes, in this particular case, dataset name, dataset description, the entity that provided the dataset, and this is important, for example, from the point of view of who paid for that study, as well as things like temporal coverage, as well as spatial coverage and variables measure and this sort of things. So, search engine. It's a search engine that works over metadata. So the other sort of sometimes confusing thing is that we don't host these data sets. We only index descriptions of data sets and help people find those descriptions. And then finally, it's a search engine of metadata from data providers. And that's why the community aspect of this product is so important, is because we are only indexing things that people want to be indexed. So in other words, we let the data provider to tell us what are the data sets they have, what are their names, what are their descriptions, and other pieces of metadata. So it's not us trying to guess all these different things and potentially making mistakes. The power of accurately describing the data is in the hands of data providers because we don't claim that we are experts in all of the different fields of science. It's up to data providers to give this information. So how do we do it? We use a standard called schema.org, which is basically a little piece of code that is embedded in the website itself. It's an open standard that had a lot of buy-in from different members of the industry, including Microsoft, Yandex, Yahoo, as well as Google, and now is being driven by a passionate community on GitHub. And it's a standard for describing different entities that could be found on the internet. And its adoption and tooling is driven by other search cases, search use cases. So for example, who has ever looked for a recipe on Google? Recipes? Great. So how we found recipes? Using the same way. So there is a recipe schema.org entity, and this is also a piece of metadata that websites that provide recipes include in their HTML pages, and this is how we find recipes. It's the same thing with jobs and the same thing with events and many others. So why is this important? It's because there are other use cases. We are buying into an existing ecosystem, and we don't have to build all of these tools ourselves. And the same way people building websites, data providers, can use tools that were designed for other use cases. The other aspect of it is that we don't build individual partnerships with each of the data repository that would be supported by proprietary code. So in other words, we don't work with individual APIs and build system to ingest those APIs and build the index. So all the outreach work that we do in terms of adoption of the standard can be reused by anyone, because those schema.org pieces of metadata out there on the web will be accessible by anyone. So anyone can build their alternative version of a dataset indexing service, which makes it more open and sustainable. And the other aspect of it is easy to add. From a data provider point of view, you don't have to build a new API. You don't have to provide a new endpoint. All you have to do is add this little piece of code into the HTML page that you're already serving to your users. This piece of meta is invisible to users, but it is being picked up by our crawlers. So how easy it is? It's so easy, it actually fits into a tweet, which we've experimentally verified recently. And this is how the minimal description of a dataset looks like. You have the definition of what standard is it, what entity is it. So it's not a recipe, it's not an event, it's not a job post, it's a dataset. And we have the name of the dataset and the description, which should be lowercase. Apologies for the typo. And this is the minimal, the very minimal amount that would be required to be eligible to be listed in search results. Of course, you can add much more, including file formats, download URLs, variables you measure, spatial temporal coverage, etc., etc. But the minimum is fairly simple to add. And then we also take advantage of existing infrastructure of crawling the web and the decades of experience that Google has in search and in indexing content. And that does depend on a couple of additional tools that are good for anyone publishing any content on the internet. So it's not just having the schema.org annotations on the web page, but it's also making sure that the web page is well represented on the web. And that includes the inclusion of sitemaps, which are tools for webmasters to tell web crawlers what sites do you have. In this case, would be which data sets do you have. And then we also provide this tool called Google Search Console, which allows a data repository to monitor the coverage of web crawling and any potential errors. Now the validation of dataset metadata is integrated in that product, so you're going to get information if something is not correct. And all those tools are supported by multiple teams that benefit from this broader ecosystem of schema.org. Okay, so now I'm going to go a little bit deeper into how dataset search actually works under the hood. So what do we do with all of this indexed data? Okay, so we index thousands of domains and millions of data sets, and we have to do a lot of data cleaning. So in other words, if you are operating at this scale and you're trying to harmonize, even at this very high level, metadata from many, many different providers, it turns out that almost everything that could go wrong or could be misspelled was misspelled at some point. So we deal with a lot of harmonization, which we use various heuristics as well as machine learning methods to clean up this data. So in search results, you're going to have the cleanup version of it. We also use internal knowledge graph to do some reconciliation of dates, locations, and organizations to provide richer results in terms of the spatial coverage of a particular data set, or, for example, the best visual representation of the university that paid for acquisition of this data set. We also have a proof of concept integration with Google Scholar, where we are looking for mentions of data sets in the literature, and we surface this information to you as well. So if a given data set was mentioned in scientific literature indexed by Google Scholar, you can see all of those mentions and explore how other people reuse this data set in science. So technically speaking, we basically tap into the Google crawling infrastructure, and we do some offline pre-processing where we do data cleaning and this reconciliation with knowledge graph. We also do replica identification, which is basically saying that we start seeing some data sets being hosted in multiple locations. It's a still small percentage of all data sets out there, but to provide high quality results, we don't want these duplicates, and we also want to figure out what is the best location to point the user to in terms of a data set. So this is sort of a similar case as with papers, when you could have a paper that is hosted on a preprint server and hosted on a publisher website, and you can, you have to figure out which one you should point the user to. And we also do scholar linking. As I said, we basically comb through all of that literature looking for unique identifiers. And we also have to figure out for a given data set what is a unique identifier, because unfortunately not all of them use an identifier system such as DOI or compact identifiers, and then things will get a little bit tricky. And then we push that to our servicing APIs, and we used another service, internal service for ranking. So we do take advantage of a lot of ranking innovations that are used in the main search product. And that's how you get the results in the search problem. So in terms of normalizing and cleaning the metadata, this is a fairly boring topic, but it is, in many cases, bread and butter what we do. If you haven't noticed that work, that means that we've been doing it well. In other words, we have inconsistencies in representation of different pieces of metadata, and we have to make them more consistent so the user is seeing things properly. So this is an example where someone was saying how one can download the data set, and as you can see, it's the first and the second and the third option here are using different field names between encoding format and file format, and distribution being an object versus being just a URL. And then the actual download format is either a MIME type in the first case, or a capitalized file extension. So we do a lot of things like that, where we take all of this and put it into a common form. Yes, so part of the ecosystem that I've talked about involves also being sort of an advocate of good practices in data publication. So we play only a small role in this bigger ecosystem, and our influence is limited, and we're trying to help mostly with findability. But the work we put into evangelizing good metadata practices hopefully will help with the other aspects. So, for example, with citations, we are big proponents of identifiers in form of DOIs or compact identifiers, which make counting mentions or citations much easier. And as we all know, citation is the currency in science. So having a good, healthy ecosystem of data citations will definitely help making data sets valuable scholarly output that will help people maintain their careers. And we also constantly talk to new data providers and developers to make sure that we increase our coverage. But in that process, we also expose people to standards in data publishing. So we're sort of this glue where we are talking to a lot of people doing similar jobs. So in other words, we talk to a lot of data publishers, and we help to share knowledge across this community of data publishers. In that process, we've learned a few lessons in the process of building this product. First of all, we really wanted to focus on the ecosystem, on trying to make this a scalable thing where we propose certain standards, help to adopt them, rather than building individual solutions for every partner. And that ecosystem aspect of it, and convincing the community that this is something worth investing into, was much more important and much harder than building any technical solution. And then we also wanted to do this using a standard that is already established. It's something that is not only used by Google, it's something that everyone can contribute to. I encourage you to check out the GitHub page for schema.org and see the discussions that are happening there. And we also, especially in the very early days, we did realize that we have to have work closely with people who are believers in this mission and have some leaders in the data publishing ecosystem to show everyone else that this is worth doing. But it paid off so far. We have around 20 million data sets and over 4,000 data repositories right now. This is a very heavy-tailed distribution. Because we are focusing on the long tail. So because to be eligible to be indexed, it's relatively easy and doesn't require any internal connections and whatnot. We are picking up very small data sets. So we range from behemoths like data.gov, which would have something like 2.5 million data sets, to a researcher from Czech Republic who published an ML data sets for face recognition. And that's the only one data set that they ever published, and they've put the metadata on their homepage where you can download the data set. So this is sort of the breadth of what we're having. But we not only limit ourselves to scientific data, we also index a lot of open government data. And that goes beyond the US and beyond the English-speaking world. We have datasets from governments from all over the world. We're relatively big in Brazil and India. And we are helping citizen scientists to move forward. We're also seeing uses in education and journalism, especially with the rise of data journalism. So it's been a very exciting journey so far. So now I'm going to switch gears a little bit, and with the hope that who's here involved in one of the many NIH data repositories? Yay! Thank you for your service. So the next bit is definitely addressed to you, but it's also useful for anyone building any content that you would like to be found on the internet. So we're going to talk about the life of a dataset search query. And this is an important point of view if you're trying to make your data findable. So it can be divided into three parts. Into querying, so actually typing the thing that you're looking for, then into scanning the results, and finally evaluating the landing page. And I'm going to put it out there straight away, although it is a spoiler, only the first two are involving really us. The third one, the landing page, is really up to the data providers. Okay, so let's talk about query. Those are some of the queries that we see or are similar to ones that we see in dataset search. And many of them are quite generic. Sometimes people will use specialized language, but quite often people start with a very generic term, and then there's the process of query refinement when people are getting some results, but they're seeing results that they don't want to see, so they add a more specific term to narrow it down. What is useful in context of that generic aspect of queries is to provide, at least to some degree, a generic description of a data set. And this is especially important because who might benefit from your data set might not be someone who you know very well. In other words, it might be an outsider to the field that you're studying. It's this conundrum of if someone is an expert in your particular field, they probably know about your resource. But your resource might be very beneficial to people from other fields, especially now with the application of ML and data science. So providing a more generic description that could cross that divide can yield large benefits. And then certain data sets might be known under different synonyms. Providing those synonyms and abbreviation also helps linking data sets, help us find data sets in literature. And also, finally, linking the data set to external entities is also very useful for building a more richer picture of not only the data set itself, but also how this data set relates to other data sets, who funded the data sets, what are the authors, and the organization involved in it. And we are promoting uses of these identifiers to do this linking in hope that one day the ecosystem will be mature enough to provide a rich context, and we can surface those in search results. So those do correspond to specific entities in the metadata standard. So the first one is obviously the description. Synonyms goes into alternate names. And then the external links, that goes into identifiers and the creators for authors. And same as is basically a way to say that this given data set is a copy or a mirror of another data set. We also have similar things for data sets that are part of other data set that would be is part of, as well as the opposite of that relation. terms of identifiers, we support and encourage people to use commonly adopted identifiers in scholarly publishing, such as digital object identifiers, but also compact identifiers, also known as the identifiers.org, which is a slightly easier to adopt scheme, both for datasets and for related articles. So we have this concept of articles that are related to a dataset. Those are usually either the data papers describing the dataset or the particular scientific publication that this dataset supports, which is slightly different than a secondary reuse of a dataset. And then in terms of researchers, both creators and maintainers, we encourage people to use ORCID. And for organizations, the Research Organization Registry, or ROR, by the DataCite people. Okay, so after the query comes scanning the results. So you do the query, maybe you refine it, and then you look at the results you have. And here the experience is slightly different from the main search product because we provide much richer description of each dataset. So this is basically what we show, but you're very much in control of what is being shown here, because that information is taken from the metadata provided by data providers. So to optimize this, what I usually encourage is an analogy to Wikipedia. So all of us read Wikipedia pages, and they almost always, especially the good ones, start with a generic, simple English description of the topic. And such approach to data sets help to bridge that divide between field experts and experts in another field that I've talked about before. So you have to sort of get outside of the bubble of the decades of experience you have in this particular field and try to include some more generic description of the particular data set to begin with. But it shouldn't come at a strict cost of the specific expert language because certain specific terms and fields could be used to query the dataset by users. So it has to be a mix of two. And finally, adding images is possible in descriptions, and we have documentation how to do this, and that makes the results more attractive, but it also makes it easier in some cases for users to decide whether this is the type of data they want, especially with imaging data of various kinds that there's so many produced here at the NIH. Okay, so that's about scanning, and there are a couple more, three more pieces of metadata that are useful. Licenses. We do know that there is a non-trivial subset of people searching for data which have a specific licensing needs. So there are private research labs. As well as private companies that, for example, only want data sets that are allowed for commercial use. So providing licensing information is very useful for these people. And same for spatial coverage and temporal coverage, if that applies to you. This is more for like historical data, economic data, as well as geographic data. So that covers scanning. And then finally, we go to the landing page. And this is something I didn't appreciate much before I started this job, myself running data repositories, because the way I interacted with the data portal I've built was like you go to the main page of your data portal, and that's the entry point. And then you start looking for data set and exploring the data sets. So whatever you've seen on the main page, you remember, you incorporate into your journey, into your cognitive image of that data set that you will find. But this is not how the journey through search engine works. People might discover your data portal through search engines, skipping any in-between pages. So it's worthwhile investing into that landing page, so it would give people more context. I would introduce the repository, Also, very important, not always obvious, make it very clear how to access the data, and if there is some procedure to gain access, what is that procedure, how people need to move forward. And finally, sometimes people will find a data set that is not exactly what they wanted, but maybe your repository actually has exactly what they do want. So if you have an internal search that searches only within your repository, exposing that easily on every landing page would help people to explore your resources better. Okay, so this finishes the journey of a dataset search user, and hopefully this will be useful for people who are trying to optimize their resources in terms of findability. And I've got a few more minutes, so I'm going to talk a little bit about our future directions that are specifically of interest to funding bodies like NIH. So we started working with schema.org on describing accurately the information about who basically paid for acquisition of a given data set. So this is information about both the funder, so here it's a government organization, as well as the particular grant number so Sarah, before you make the picture, I'm going to stress out that this is work in progress. So, which means please do take a picture. But the details of this might change. The bottom line here is that we are interested in helping providing a consistent way for data repositories to provide this information, which hopefully will make it easier to, for example, sometime in the future, look for all the data set produced, published for a given grant number or for a given organization. So hopefully this is something that will help quite a few people around here. So this is all I've got for today. I thank you very much for your attention, and I'm open to questions.
There are 104 people listening online. If there are people online who have questions, you can email them to me, adamT@nih.gov, or you can send them to me on Twitter, DAM Adam, and I will repeat them to Chris. But go ahead here.
Hey.
Hello.
Many people think of Google as one of the biggest creator of data sets. So how many data sets is Google contributing to the data search database?
So I'm going to repeat the question for the people listening. Google is considered as the biggest creator of data sets, as you said. I don't know if that's true, really. But the question really is how many data sets Google contributed to Dataset Search. And it's a great question, and we have Google AI has a list of published data sets, and all of them are indexed in Dataset Search. This is not a large number, as in I think it's at most something like 20 or 30 different data sets. Most of them are very driven by a particular machine learning use. Google sister or other alphabet companies such as Waymo also publish data sets, and we try to make sure that they are being indexed there as well. So to answer your question, those that are published by Google we index, but it's not a huge number in terms of how many data sets Google actually publishes. I'm pretty sure the NIH publishes orders of magnitude more than Google does.
So none of the web indexing data that Google creates is there.
So the question is none of the. So the question is about like the web indexing data sets. So there is a data set, I believe, published by Google that was for a competition to help with ranking. And it has basically queries and matching search results. And this was before Dataset Search, but that dataset is public, and I believe it's indexed by dataset search. So that's something, the type of dataset that you're interested in.
So Chris, thank you for the very interesting talk. As you were talking, I was playing around with it.
Woo! Did it break?
So what I noticed was you made a distinction in one of your slides about data sets and data repositories. But when you do the search, you actually find both. There's no category. Is that correct?
Yeah, that is correct. We have some providers that label data repositories as datasets. And I understand the ontological distinction, but we haven't found the fact that those show up, especially for generic queries, to be detrimental for user experience so far. That might change in the future, but that's why we sort of don't crack down on this. So.
And most of the work that you're doing, that Google is doing, is really to automate the process of finding repositories and organizing them, right? So in other words, for example, I was just putting in the term TCGA, the cancer genome analysis. What I found was one repository on AWS. I didn't find the one on Google Cloud Platform. That's because whoever put the data on AWS, they have a page that's descriptive enough for you to pick up, but not the person who put it on Google. Is that the reason why?
That is the reason why. And that's why this all work with partnership and making sure that metadata is being added to those pages is so important, because we are not indexing pages which do not explicitly tell us, yes, I'm a data set, yes, I want to be included in search results.
Right. So for the NIH as a funding agency, of course, we found a lot of data sets or data repositories. Is there a way for funding agencies, or the term you use, I believe, is the owner of the data set, to claim that data set and say, this is something I created, or we found it, and this metadata is not correct, and how do we correct it?
Yeah, so it's a great question, and I think the best way to go around it is you as the primary source of the data to annotate with the metadata your resource, and we'll basically make sure that either we deduplicate these things, or they will at least show higher up in the rankings. But the bottom line is that if you publish a data set and you want to be represented accurately in search results, you should make sure that you add the metadata to your landing page. And there are many wonderful data resources at the NIH, which I think would benefit greatly from adding those pieces of metadata.
Thank you very much.
Sorry. We'll get back.
So another middle entity in this process is like the growth of academic data journals, or journals that are linking to data sets. And it's interesting because they don't generally host the data, but that's the data descriptor.
Yep.
But so sort of the first part of the question is like, how does that interact with this? The second part is the fields they ask for are much more like keywords or the scientific keywords. They're not those data journals aren't collecting these sort of generic terms that would be useful for this. So what is your thought that should the data journals be collecting this schema as part of their service, and how do they interact with it?
Yeah, so the question was about data papers and how do they interact, and data journals and how do they sort of fit in this ecosystem, what role should they play. So I think the biggest benefit of data journals and data papers is that they incentivize scientists to publish data, and they give scientists back something that is recognizable in the scientific sphere. In terms of us interacting with those journals, we talk, for example, a lot with scientific data because we have a lot of topics in common in terms of metadata and what makes a good repository and things like that. But we do not index those papers directly. We index the repositories. They require their authors to put the data in. And those repositories will usually put in their metadata the information about what is the related data paper. And we will surface that information in search results. In terms of the description, I haven't thought about it, but this is a very good point that the data papers do not emphasize this like cross-field reuse of data, and often data descriptors or data papers are still very sort of like soaked in the like field-specific nomenclature. It might be interesting to bring that up and maybe talk to the editors of some of the major. That's something that we can definitely. It's a great idea.
Along those veins, can you publish, or maybe this is a naive question, you've already done it and I'm not aware, but can you publish your standards or like get it out to the wider academic community about the points on generic language, synonyms, and external links?
Yeah, sure, of course. Yes, so this is actually a paper that was published, that was presented a couple of weeks ago. I think it didn't hit the preprint servers yet, but will be out there. And in terms of the actual specification, not those sort of general guidelines as I presented them here, but the actual specification, all of that documentation is online and it's under the first link there. So we're definitely investing a lot into disseminating those guidelines, but that specific stuff, I think it would be great to put out as well. So I saw some hands. Adam, is that a Twitter question?
Yeah, I've got a question from online. This is from Durga Adapali. Her question is, what is the limit of the metadata which can be added to the schema.org HTML?
Yeah, so what is the limit of the metadata added to schema.org? So there are limits in terms of the types of field we index, and under this documentation links, you're going to see all of the different fields that we do index. Schema.org has many more fields, but we sort of have to start somewhere. So that limitation number 2, and the other limitation is the size of the total metadata description, and we also provide information there on like how large that description can be. So I believe it's right now at 5,000 characters. But don't quote me on that. Check the documentation. There were more questions, but I forgot. Okay.
So this is great. And it strikes me that there's a few types of data that don't fit neatly into this kind of framework, right? So I'm imagining the first one that came to mind. I know there's like web dumps of this, right? In some ways, Wikipedia is just like a big data set. And then there's also data kind of access for like web APIs that might give you access to data, but it's hard to see how they would be indexed in something like this. Are you guys thinking about that?
Yeah, so we're definitely thinking about it. So the question was, what about these edge cases, such as data sets that are also corpuses of text, such as Wikipedia? What about data sets that are live, such as streams of data or APIs? So those are definitely something that we eventually would like to look into. Right now, we're focusing on the sort of 80-20, like the majority of things. Some of this can be already done. Like if you have an API, you can annotate it as a data set, and people will still find it. They're just going to interact with it differently. But it is definitely something that we are thinking about. Sir?
Quantify reuse that what you're doing, making it more available, easier to find, is increasing reuse of data.
So it's a great question. How do we quantify / evaluate whether increasing findability actually does increase reuse? The short answer is we don't. It's a very hard question because it's a very convoluted route. Because if you talk about scientific reuse, it goes from someone having an idea, going to Dataset Search, making a query, clicking on a data set, and that's where we lose them. And then some of them will decide this is not for them. Some of them will download the data set, decide this is not for them. Some of them will download the data set, analyze the data set, and decide that there's nothing interesting there. Some of them will download the data set, find something, and won't be able to publish it. And eventually someone will actually publish. And that's where that's the sort of the gold standard of reuse. Someone actually published a novel finding on this paper. And now figuring out which of the data reuses, already finding data reuses is not trivial but tractable. And I think that we're going to make huge progress on that in various different organizations. It is hard. But then distinguishing which of them actually Dataset Search help with is hard. I would love to know that because for me, ultimately, that's the biggest motivation. But we can only use proxies, looking at whether people come back, whether people actually use the tool on a regular basis, because we can assume that this is not, a common hobby. People actually gain some productivity advantage from it, but that is a proxy. But it is a very important question, which I think we should ask ourselves a lot. Dan.
We had a request from Twitter to mic the audience.
So you were talking about extending fields, like, for example, with funding bodies information. The other potential extension would be ethics boards, so human subjects boards or animal research boards. So, this if it's a study in those categories, you can have it was approved by this board on this protocol number, because that's information that definitely there might be needs in the short term or long term to sort of easily pull that information up as well.
So like ethical board approvals,
Yes.
This sort of stuff. Very interesting. We haven't thought about this. It's a great idea. We should definitely talk afterwards and figure out. That would also be something that will go through schema.org with a public call for comments and stuff like that.
Hi. You showed linking to a paper related to data sets. Can one also have a data set under a publication and link it that way, like both directions? Does that make sense? Can they use the data set schema in a publication to reference in a?
So let me ask a clarifying question. So are you asking whether someone can, whether you're a publisher of papers, can you use
Yes.
schema.org?
Yeah, using schema.org for your the citation, the publication, but can you add then the data set under that?
So I'm not sure if you've seen that happening, but I can definitely see how this would work and would be supported. Where if you are a publisher of scholarly work and you know that this paper is using that data set, you can add the description of that data set there on that page and the information that this is the paper that it links to. We would be able to take that in, and if we have information about this data set somewhere else, we would incorporate that together. If we don't, then we would send users back to the paper page, but it's still better than nothing and still a good entry point. So I think that's a good idea.
So in many cases, when you're sharing data, you sort of upload it to a repository that you might not have control of HTML code. So for example, nitric.org. Is there a workaround to still provide the metadata that's necessary to get indexed?
Is there a workaround there? So yes, there are some sort of hacky workarounds that would put you in control. We have a blog post describing how you can write indexable descriptions of dataset on GitHub. So you can definitely do that for all of your data sets. But in principle, I do recommend choosing repositories that do support schema.org. In terms of Nitric, we are in conversations with them and trying to convince them to adopt it as well. Sometimes it's like, I think in terms of Nitric, they're dependent of XNAT, and they sort of wait until XNAT does it, and XNAT has other things to do. So sometimes it's tricky. But there are workarounds, but if you can, it's definitely better to upload stuff to repositories that support schema.org. For example, the nih.fixture.com does support schema.org. I saw another one. Yes.
This might be a very simple question. The search is super simple right now. What are your priorities for adding kind of options for how users can filter? And then I guess I had a second question about whether there were any limits to the repositories that the Dataset Search could link to, or how Google is prioritizing which repositories to include in the search.
Yes. So to answer the first question, unfortunately, it will be a very disappointing answer. The company has a policy not to talk about features that are unreleased, but I can say that we're definitely very interested in adding this, and what I would love to know from you is what type of filters or facets you would find the most useful in this product. Is there a microphone? Oh.
Excuse me.
Yeah, well.
You should probably ask everyone in the room because we probably all have our own priority filters.
Well,
right?
And I also don't want to put you on the spotlight, but there is a feedback button on the website where you can click and tell us everything you want to tell us, including what filters we should add. And then genuinely, we are a user-driven product, so we love to know what filters you would like to have there. And to answer your second question, which was how do we prioritize which data repository to include or not, the answer is we do not prioritize or deprioritize any data sets because it's up to the data repository to add the metadata. If you added the metadata, then we will index you. If you don't have the metadata, we will not index you. So it's up to the data providers to make that step. And it also puts them into control of like what metadata is there. We do have outreach programs, and we have certain pushes towards, we're going to talk to all NSF-sponsored repositories now. We're going to look at all the economics and stuff like that. And but those are just sort of developer relationship programs where when we talk to data repositories, we don't index data repositories that do not want to be indexed.
So your funding slide was interesting. You know you're going to have a huge mess with identifiers, funder names, all of that. I mean, because is this NIH or is this the National Institute of Mental Health? Does the grant name have NIH in front of it? The numbers, all of that stuff. So
I'm looking forward to this fun.
All right. Because are we HHS? Are we NIH? You know, where are we in the line of government? And there can be a U.S. version, a U.K. version.
Oh yeah. I also learned that there's this whole world outside of this country.
I've heard of that.
So just adding to the filter comment, I was playing around with it. Immediately, I noticed that you have, for example, data sets from Figshare. You have data source data set like TCGA from the NCI. So immediately I was thinking, if there were a filter, just to filter if it's analyzed data or source data, that will be very useful because there's a lot of search results to go through for large data sets like TCGA.
Interesting. Yeah, I think that would also require a little bit of schema.org work in terms of the vocabulary and the fields that describe this particular distinction. But good feedback. Sorry.
Speaking of funding, how many people at Google work on this project, and what is the sort of the revenue structure for?
Oh yeah. So I'm not sure I can disclose that information, and I can tell you that this is part of a project called Data Science for Social Good, part of the research organization. So that should give some hints about the revenue stream or lack of it. And yeah, it's not a large team. It's a small team, but hopefully product is good. And if it isn't, please let me know how we can improve it.
There's one more question from the Twitters. Is there any linking between data sets?
Linking between data sets?
Derived data sets, for example.
So what was the one?
Derived
data sets. So we do support providing information about replicas, derived data sets. Data sets are part of another data set. And right now we are heavily relying on replica information. So there are there are ways to do it. We already incorporate some of them into the results, and we hope that we can improve that in the future.
One more question about how you order the search results. So when someone searches for a specific data set, does it bring out everything associated with that, and how does it rank?
Yeah.
Is it similar to how the regular Google works, or is there some special ranking that you use?
It's very similar to how the regular Google works. We actually used same or similar APIs built internally for ranking. There are some small tweaks that we had to do for the replicas and making sure that we get diverse enough results. It's a very complex mechanism that incorporates decades of experience that Google has, and I do not know all the details of it myself. If there are some improvements or shortcomings of ranking and dataset search, please let me know, and I will pass it on and make sure it's not going to happen again.
So I guess since you're asking for a lot of commitment from other people to support this, I guess the long term, and it's a follow-up of the revenue stream, how can we be convinced of Google's support in the long term for this? It seems like Google has a lot of products they try for a little bit and then they vanish, and so you're creating this infrastructure. Do you think it would survive without Google, or are you asking people to invest in something that's a bit of a trial balloon for the company?
Yes, so it's a great question. And the answer is that Google is not the only search engine that is picking up schema.org. Bing picks it up as well, Yandex as well. Not particularly schema.org datasets, but they could if they wanted in the future. And anyone can build a tool that would crawl this metadata in the future. So if, as you sort of hypothetically ask, what will happen if this product will be discontinued, this effort in standardizing the way data repositories advertise their data will be there for anyone to take advantage of. And if it is a need that needs to be fulfilled, which I believe strongly there is a need for a product like this, someone else will pick it up, and they will have this curated ecosystem of everyone using the same standard. And hopefully this answers your question. I just want to comment there that yes, it is true that certain products were discontinued. I very much believe in this one, and I hope it fulfills an important role. But if it doesn't, then maybe it shouldn't be there. So if we can work together to make it better, I hope that we'll be there for many years to come, as it is the case for Google Scholar, for example.
All right, I think we should wrap up there. Let's thank Chris again.